Right. So can you see my slide?
Hello.
Yes.
Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Baik,
Can
Datuk.
you see? Ya, boleh nampak slide
Clear, Datuk.
Boleh Datuk.
Boleh Alright. So our class will be start at 2:30 lah. So we have another 2 minutes. We wait for others. Okay. So today we focus on the new, the last topic lah for our subject AI. Okay, so let's start our lecture for today. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all of you. Alright, so today we go for the last topic or last chapter for our subject for AI. This is multi-layer neural networks and the backpropagation algorithms. Alright, so this is also the last topic for AI. Last topic for artificial neural network lah. Alright, so we be covered on the multi-layer neural networks. Actually, multi-layer neural network is we known as the feed-forward neural network lah. And the backpropagation algorithm is actually the techniques, the techniques how the weights will be adapt, how the weight and bias will be adapt lah. So we'll be on using the backpropagation algorithms. Okay, this is the learning we call the learning algorithm lah. Okay. Okay, so this is our objective for this topic. First is to understand what is the multi-layer neural network. Okay, that I mentioned to you. So multi-layer neural network is the feed-forward neural networks. Okay, that we have the three types of the topologies of the neural networks. We have the feed-forwards. Okay, we have the feedbacks, and also we have the caesular lah. Okay, so multi-layer neural network is more on the feed-forward neural network lah. And then second objective to understand the rules and action of the logistics attribution function, which is used in the basis for the many neurons, especially in the backpropagation algorithm lah. Alright, so before this, on the simple neural network, we use the threshold. We use the threshold as the logistic attribution function, right? So for example, the threshold we set as a 2, so the output refer to the threshold lah. And then objective number 3 is to study and derive the backpropagation algorithm lah. That is the learning algorithm. Alright, so we have to derive how the weights and the bias will be adapt. So also for the multi-layer neural network, they have or the backpropagation, they have the standard formula. The standard formula to adapt the weights and also to adapt the bias. Okay, and next objective is to learn how the backpropagation algorithm is used to solve the simple problem lah. Okay, yeah, sorry. Right, so any question? Okay, next we go for the last but not least for the objective is that to try some hands-on exercise for understanding the backpropagation algorithm lah. So this one will be covered for the last lah. Okay, so we will do some exercise. So how the backpropagation algorithm can be applied to solve the simple problem. Right, so this is a multi-layer neural network that I mentioned to you. So this multilayer neural network known as the feed forward. That means from the inputs to the outputs. So in the middle we have we call the header layer lah. So maybe we have one header layer or two header layer or three header layer. Okay, depend on the system lah. Right, for simplicity normally we use only one header layer lah. That means we have the inputs. Okay, we have the header layer and also the output. Okay, this one no feedback. Okay, no feedbacks. All right, so this multilayer is that's why we call as the feed forward. That means from the inputs, okay, to the outputs. Ni. Right, so the multilayer neural networks, in addition of the hidden layer of the neuron in the perceptron, allow the solution of non-linear problems such as XOR and many practical applications. So you can see this one. Some of the multilayer neural network, they use the perceptron. We will cover before this on the simple neural networks. Okay, so a lot of practical application using the backpropagation algorithm lah. The backpropagation algorithm is the learning algorithm lah. So however, the difficulty of adaptation of weights, okay, and also the bias between the hidden layer and the input layer of the multilayer perceptron have them such architecture during the 60s, right? So which discover of the backpropagation algorithm by Rumelhart, okay, Winston and Williams in 1985. So the adaptation of the weights in the lower layer of the multilayer neural network are now possible lah. Okay, that means from that's why we call the backpropagation. So that means our weights and bias will be added from the output, okay, from the outputs to inputs. Okay, that's why we call it backpropagation. From the output to the input. That means our weight and bias will be added at the output part first, then go for the hidden layer, then go for the input layer. That's why we call the backpropagation algorithms. Okay, so the researchers propose the use of semi-linear neurons with differentiable artificial function in hidden layer in hidden neuron, referred to the logistic artificial function or Sigmoid, okay, which allow the possibility of the adaptation. All right, so next we go for the logistic artificial function, or sometimes we call the Sigmoid. Okay, so actually the artificial function is similar like threshold. Threshold is one of the artificial function. Right, so next the artificial function play an important role in the many applications. So in the early years, so their role is mainly to fire on unfired neuron. So similar like before this that I mentioned to you. So if for example, okay, for example, we set our threshold is equal to 2. So after we calculate the next input, okay, the formula for net input is the B plus summation of Xi Wi. So this is standard lah. And then after you calculate, okay, you get net input, then compare with threshold lah to get the output. So if the output greater than or equal with threshold, so that means our output will be 1. If less than threshold, so our output will be 0. That's why we the function of the threshold threshold is to fire or unfire lah. Okay, that means to give the output either the fire or unfire will be 0 or 1 lah. Similar like this one, similar like another artificial function, for example like Sigmoid, right? So many artificial function used in the neural networks nowadays produce a continuous value rather than discrete. Okay, the most one of the most popular artificial function is used in the logistic artificial function, or more popularly referred as the Sigmoid function. Okay, Sigmoid function. That's why next we use for Sigmoid. Okay, after that I will show you the equation using the Sigmoid. Right, the Sigmoid function is a semi-linear, is in characteristics, differentiables, and produce value from 0 to 1. Right. Okay, so that means the output can be from 0 to 1. Right. So so this is a formula. Actually, s x we can declare as the s. Similar like this one. Okay. This slide they use the x. Maybe you can change to s lah. So we standardize. We use the x. We use the s lah. Okay. Summation of si wi. That is a standard. And then the Sigmoid function is formula for Sigmoid function. Right. So this one we can declare as the s lah. Okay. For example, like before this we get the for example, okay, s equals to 2. All right, so that is for output 1 over 1 plus exponent of negative 2. Okay, that is the output you get the output. Okay, using your calculator you can get the okay, the output Okay, for example, this one, okay, you can try using your calculator. Okay, all right, so negative 2 exponent negative 2. Okay, plus 1. Okay, 1 over. Right, so will be 0.88 0.881 Okay, you can try this one So for example, our s equals to, after you calculate this one the net input s, so s equal to 2, the output will be, okay, using this formula lah. This one we call the Sigmoid function, okay, or we call it activation function similar, this one function similar like threshold lah. Okay, we threshold is like our activation function. All right, so this one also is an activation function. We use the Sigmoid function So this is formula formula for Sigmoid function, 1 over 1 plus exponent of negative s. Okay, so on the slide they use the x. Actually s, before this we use the s lah. Okay, you can change on your slide lah. So we refer to s. Okay, we refer to s lah. Right, so there is some example So for another example, maybe after you calculate the s, you can get for example 4. So automatically you can apply, okay, using this equation to get the output the output of y So 1 over exponent of 4. Okay, and then you can using your calculator to get this, what is the value for the output. All right, so this is something like this one Okay, so for example, before this we have the threshold. Our threshold something like this. Okay. This one is our sigmoid so they have something like semi-linear. We call it semi-linear So this sigmoid function we call it semi-linear lah. Alright, so this one something like this. Okay, this is for example like threshold Okay, equal to 2, so our threshold equal to 2 lah. Less than this one will be 0. Equals 2 or more than 2 will be 1 lah. Alright, so this one they have some value lah. The value range from negative from 0 to 1 from 0 to 1. Okay, that is the Sigmoid function that is formula formula for Sigmoid function 1 over s plus exponent of negative s, okay, or negative x Alright, so next we go for the backpropagation algorithm that I mentioned to you. The backpropagation algorithm is the learning algorithm. So that is the technique how we adapt the weight and bias So the learning in the multilayer network proceed the same way as for perceptron. Okay, similar like simple network on the perceptrons. Okay, the training set of the input pattern are presented to the networks. The network computes as output pattern, and if there is an error, or in other words, is a difference between the actuals and desired output patterns, so the weight are adjusted to reduce the error. Alright, similar like perceptron. One of the learning algorithm for the multilayer neural network is the backpropagation So that mentioned to you before this, we call the backpropagation. That means we adapt from the, okay, so for example, this one for input, this one hidden layer, and this one for output Okay, so this maybe we call it hidden layer, and then this is input. So we adapt from the output. Okay, we adapt this one part. Okay, this one first for the output part, and then we go for the hidden layer, and we go for the input layer. So that's why we call the backpropagation That means we adapt the weight and bias from the output to the input. That's why we call the backpropagation algorithms. Right, so the BP, the backpropagation algorithm, is perhaps most popular and widely used for neural paradigms. Okay, the DP algorithm is based on the generalized data rule proposed by DPD. research group in 1985, headed by Dave Rumerhart, based on the Stanford University in USA. So the BP algorithm overcame the limitation of the perceptron algorithm. Actually, on the simple network, okay, so they have certain limitation. That's why the limitation on the learning, okay, on the learning algorithm, how to adapt the weight and bias. That's why this Dave Rumerhart introduced one technique that we call the backpropagation to overcome the limitation of the perceptron algorithms, right? So among the first application of the BP is the speech synthesis called NetTalks, developed by Terence Cisnowski. Right, so the BP algorithm created a sensation when the larger number of the researcher used for many applications and reported its successful result in the many technical conference. This is some introduction of the backpropagation. All right, so before the BP can be used, so it requires the target pattern or signal. All right, so this one also we call the supervised learning. We give the target, or we give the target pattern, or we provide the training. Not training, is provide the target lah. We provide the target. That's why we call the supervised learning algorithm lah. And then the training pattern are obtained from the samples of the types of inputs to be given to the multilayer neural networks, and their answer are identified by the researcher. Okay, example of the training pattern are samples of the handwriting character, okay, process data, and so on, following the task to be solved. Okay. And then the objective of the learning algorithm, similar like before this, to minimize the error. Okay, that is I think it's the standard lah. It's a standard for why we need to adapt our weight and bias, because we want to reduce the error. Okay, reduce the error between the target and the actual output, and find the this is delta W is the new adaptation of weight, new adaptation of weight or bias lah. That is the objective lah for the learning algorithm. All the learning algorithm is the same objective. I think is to minimize the error, to minimize the error between the target and actual lah. Alright, so the error is calculated at every iteration. Alright, so and it propagated through the layer of the neural network to adapt the weights. Okay, the weights are adapted such that the error is minimized. So once the error is reached a justified minimum value, then the training will be stopped lah. Okay, similar like simple neural network. So after you error less than error minimum, then the training can be stopped lah. You can stop the training because we reach the minimum value lah, minimum value for the error. So we can stop the training lah, and then we can go for the recall modes. Okay, that means recall will be is the application lah, to solve the task lah. Okay, so this you can see there's some example on the flow of how the backpropagation works. So this is input pattern, output, this is a target, and then actually this is error. So the weights and bias will be added from the output lah. Okay, output, and then go back to the inputs. Right, that's why we call the backpropagation algorithms. Okay, so in general, the process involved in the backpropagation network are first, training the input pattern are presented to the network's input layer. And then the network that propagates the input pattern from the layer to the layer until the output pattern is generated by the output layer lah. If this pattern is different from the desired output, so an error is calculated, then propagate backward through the network from the output layer to input layer. So the weight are modified as the error is propagated. Okay, so this one, so to derive the backpropagation learning law, let's consider the 3-layer network shown in the figure below lah. So we assume this one, Okay, so for example, this is a input layer. Okay, we declare as the 1, 2, we declare as I and N, and then this is hidden layer. Okay, in the middle we call the hidden layer. Okay, declare as the 1, 2, J and M, and also the output layer lah. Okay, they declare as the 1, 2, K and L lah. right? So okay, so the input signal, okay, input signal, this one, this is the input x1, x2 until xn, right? Propagate through the network from the left, okay, from this one, this part to the right. And then from this right, you have to find the error, okay, find the error on the output back to the inputs, okay. The symbol of Wij donates to the weights. Okay, this one we call it weight here. So this one we call the weight, and this one that mentioned to you before this. So every point here actually, every point here, so we have the weight lah. So up to you, we can declare as a Y1. Okay, for example, this one we declare as the Y2, Y2, sorry, W2. Okay, this one W3, and this one W4. Up to you. Okay, maybe you can declare this one 111. W12, W13, for example, right? And then the neuron I is the input layer lah. Okay, this one for input layer, and for K and L, okay, is for the output layer lah. Okay. Next, we go for the calculate the error. So to propagate the error signal, we start from the output layer. Make sure here. So to get the error, so we have to calculate from this part. Okay, for example, from this part lah, from the output layer. So that's why we can get this equation. Actually, this is a given. So this is our pattern lah, our target. This one we call our target, and this one we have to calculate. Through the from this network. We can get how to get the error. After that, I will show you how to get this error. So this one we have to calculate from, okay, this one we have to calculate from the input. Okay, this one, this part from the input to the output. But the error here actually is come from the output. You have to calculate on the output on this part. Okay, on this part here. Okay, that is formula lah. Okay, formula to calculate the error signal at the output neurons. Okay, so y on the targets, okay, minus y calculated lah. Alright, and then this one we will indicate is the desired output of the neuron k at the iteration p lah. So this one normally will be given. This one will be given. Alright, so the rule for the updating weight at the output layer is, okay, so similar like this. Okay, before this on the simple network, you will use like this. Maybe you can write like this lah for simplicity. So if new, okay, if new one, okay, you declare a new one, okay, with old, okay, plus alpha j, okay, is the gradient error. Alright, similar like before this lah on the simple network. Similar. So okay, so this one will be, this one old, we call it old. Okay, this one will be new, we call it new. Okay, this one will be with old plus is this one summation of summation of alpha. Okay, alpha is the learning rate. Okay, alpha is the learning rate, normally will be givens, and then we have the gradients. Okay, error gradients. This one we have to calculate that. Okay, after that I will show you the formula to calculate the error gradients. Okay, and then this is the, okay, it's the y lah, the output on the y, this one on this part. Okay, so this is error gradients is determined as the derivative of the activation function multiplied by the error at the neuron output lah. So this one so this is how to calculate the gradient error. So this formula gradient error, and then from this one, actually this is our how to calculate the output. The output. That's why from this one, substitute this formula. This formula actually is to calculate the y. Okay, the y. So is the using the sigmoid equals to y over 1 plus summation of es, or okay, exponent of negative s lah. Similar like this. We call the similar like this. Okay, and then at the end multiply by error, so we get this this equation, and then simplify. Okay, after simplify, so this is our gradients error gradients lah. This one this one we call it error gradients. Gradients. Okay, this is formula lah. Formula this is formula for error gradient lah. Y, okay, Y is the depends on the which one. Okay, the neuron lah. For example, okay, this one. So this input we declare as the 1, 2, 3. Okay, maybe we declare as a S1, S2, S3 lah. Okay, this is the input, and then this is the output. Okay, for example like this. So this Y here. Okay, Y here. So Y we call S3 lah. We call Y S3. Okay, so this term on the K part lah, on the neuron. Which one the neuron? Okay, the output, the error on your calculator on which neuron lah. For example, this one we study on the neuron on the S3. So that's why we can name as the Y S3. Okay, this one on the K neuron lah. So if you refer to the diagram, so this one on the K neurons. That's why you name as the YK lah here. So that's why I mentioned to you. This is on the neuron. Neuron. This is iteration number 1 or 2 or 3 and so on. Okay, and then this is formula to calculate the gradients, error gradients. Y output multiplied by 1 minus output multiplied by error. Okay, error also, this one also we have to calculate it lah. Okay, and then this is standard formula. Okay, same formula for output using the sigmoid plus of S lah. Okay, so S actually is declared as the X. Okay, X. And then to calculate the weights correction, okay, that means we have to add the weight of the hidden layer. We can apply the same equation for the output. Okay, the standard formula for hidden layer will be same lah. Okay, this is for added the weight and also added the bias. Also similar lah. Okay, this is this means you want to add the weight. Okay, so this is weight new. Okay, so this is weight all. Okay, plus addition of weight lah. So this is formula so equals to weight all plus alpha, X is the input, and gradients error. Okay, gradient error. Gradient error at which neuron? Okay, which neuron? For example, for J neuron. So this one okay, for this one. Okay, you can see on the slide for J. Which one J here? Okay, here for J neurons. But the input from the here from the I. Okay, from the I. That's why if you can see this one is come from the input lah. The input is I, but this one is come from the gradient error from the J. Okay, from the J, because we added on the this neuron and then this is a gradient error in the hidden layer. Okay, same formula before this, you can see. All right, so that's formula. Output multiplied by 1 minus output multiplied by, okay, so this is different compared than before this. Actually it's the same. So this is sorry, actually this is we call the error. So this one also formula for error. That's why they calculate the gradient error for K multiplied by weights. Okay, weight at the J and K at the P iteration lah. Alright, so this is another formula. Okay, to calculate the output. Okay, that is standard . So maybe maybe if you are familiar like this, maybe you can set like this 1 plus summation of S lah. Okay, this one they use the X. Okay, XJP. Okay, this one refer to which neuron. So maybe you can declare as the S1. Okay, for example, S1 or S2 or S3 lah. Alright, and then also this one. Okay, this one to calculate the input. Okay, okay, so this similar like S equals to B plus summation of XI WI. Okay, similar like this one. So this actually this slide is, okay, maybe on the simple word we refer as the S. We refer as the S, but this slide they refer as the XJ because of, for example, okay, this one for like our middle line. Okay, for example, middle line. So we have 3. We have 3. That's why we declare as S1, S2, S3 lah. Similar like this one lah. So first we have to calculate the S1. Okay, S1, B1 plus submission of. Yeah, but this is standard lah. S2 will be same, B plus submission of SI, WI. So this one also similar. Okay, this one we can call as the S. So they are mentioned on the J, on the neuron J lah. Maybe you can set as the S1 or S2, S3. Okay, this is just a name, name of the neuron lah. Okay, if you name it as the S1, so maybe you can refer to S1 lah. Right, so this is step, This is step to on the backpropagation algorithms. The first step is the initialization, right? So first we have to set the all the weights and bias. So that mentioned to you for simplicity, normally all the weight we set as the 0 and bias we set as the 1. Okay, it's normal. It's for simplicity, or also you can set as the 0, up to you. Okay. But so normally they mentioned to you, so the weight equals to 0 and the bias equals to 1. Okay. And then second step will be activation function. Okay. So we have to calculate the for output lah, for every neuron. Okay. For output calculate. For example, we have the, okay, for example like this one. Okay, this output like this. Okay. For example, this some example. Okay, so first we have to calculate the S1. Okay, this one we calculate S1, S2, S3 lah, for example. This one S4, similar like middle line. Okay, first step you have to calculate the S1 here, and then you have to calculate the S2, and then you have to calculate the S3. Then you can get the output here. So the output here, Y we can declare as Y S1, this one Y S2, this one declare as a Y S3. But the output here will be input for this one X. Okay, X here, X S4 will be Y S1. Okay, this means the output here, the output on the S2 actually is the input for the S4 on this part lah. Okay, clear this one. Okay, similar like this one. The output for S2 actually is the input for S4 here. Similar like S3, So the output here you can get S, and then you can use this formula to get the Y. Actually, Y here will be input. Okay, will be input for this one, for this S4 lah. Okay. Right, this is a second step. Okay, similar. So you have to calculate the every lah for step number 2. On part B, you have to calculate for every lah. For example, first step, calculate this one, calculate this one, calculate this one, calculate this one. At the end, you can get Y here, Y output lah. Up to you. You want to declare as the YS4, YP, up to you. So for simplicity, maybe you can set as the YS4 lah, the output here. Okay, the output here. Then we can calculate the error lah. Okay. Okay. So next step 3. Step 3, we have to adapt the weights. Okay, adapt the weight and bias lah using this formula. But to adapt the weight and bias, okay, we have to calculate the error gradient. Okay, error gradient. This is formula for error gradient lah. This is standard formula for error gradient at the output layer. Output layer, because on the hidden layer or input layer, so on this part will be different lah. Okay, for the output layer will be multiplied by this error. This error. Okay, this error, how to get this one So this one error so this one normally given. Alright, so this one you have to calculate it lah. Okay, calculated from the input to the output. Okay, and then you can get this one. Okay, so minus you have to given minus with output calculated lah. So you get the error. So from get error you can calculate the gradient error here. Okay, there is formula lah. Formula for calculate the gradient error. So don't worry, the formula, every formula will be given for the so this one will be not cover for the midterm. For the midterm not cover, so maybe on the final. So that's why all the formula will be given. No need to memorize the formula, but we have to know lah. So you have to know. For example, this one, what mean this K mean? Okay, the K mean, actually the K is on the neurons. Okay, for example, for my simplicity, I declare K as the S4 lah. Okay, then this means you can calculate the E S4. Okay, E S4 lah. For example, like I mentioned to you, so similar like this. Okay, this one I declare as S1, S2, S3, S4. Okay, this is the output lah. Okay, this is the output Y S4. Okay, so Y given, okay, Y given minus Y S4. Okay, this one, all right, to get the error. So maybe I declare as the error S4. Okay, so here on this slide they refers to neuron K. So on the, you can refer on the figure lah. So they refer the neuron K at the P iteration lah. This one is, we call it iteration. Maybe we declare as the iteration 1 lah. So maybe we can declare as the neuron K at iteration 1. Okay, for example like this. For simplicity, I declare as the ES4 lah. ES4 at the iteration 1. Okay, iteration 1. Put as the 1 lah. Okay, that is formula to adapt the weights. Okay, but you have first to adapt the weight, you have to calculate the error gradients lah. And then after you can get, calculate the gradients, error gradients, you have to calculate the weights. Okay, this one similar like simple neural network. Actually, this we call a new lah, new, and this is old weight. Okay, plus, okay, this is a similar like this one lah. We substitute this formula So alpha yj, okay, and then multiply by gradients error. Okay, S4 lah, I declare as S4. Okay, for example like this. Similar like simple neural network but this one they are separate. Okay, this one actually is the adaptation weight correction lah here So just maybe you can memorize this formula also. I think, but not need to memorize because this formula will be given okay, to adapt the weight, how to adapt the weight and bias using the formula. So this formula will be given all right, and then next you have to calculate the error gradient at the hidden layer. Okay, before this you calculate the error gradient at the output now at the hidden layer. So the hidden layer part on this part will be different. Okay, on this part will be different. So this one will be same if you refer on this one. Okay, this part will be same, but on this part lah. So on output will be different lah. So this one, the gradients, okay, the error gradients at the K neurons, okay, multiply by weights, okay, weight at the J and K, okay, weight J and K, and iteration 1 lah. Okay, so you have to adapt the weight and also the bias lah. Same formula So adapt the weight and bias will be same. Okay, this one will be, I declare as the old, okay, plus alpha x I is the depend on what iteration, and then multiply by gradient j lah. So for example, before this you are update on the S4 or S3 or S2 or S1 lah. So maybe I declare as the S1 gradient on the S1 lah. Okay, so this one will be input x this will be input on the iteration. What is the iteration? For example, iteration 1, okay, will be input for iteration 1 lah. Okay, so alpha learning rate normally will be given lah. Okay, next for step 4 will be increase the iteration p by 1, go back to the step 2 and repeat the process until selected error criterion is satisfied lah. That means after we get the error less than error minimum lah, then we can stop. Okay, we can stop the trainings. All right, so maybe you not understand on the derivation, so we can try. Okay, we can I will show you, okay, from the examples here. Okay, so you can see this one, this some example, okay, on the backpropagation. All right, so that mentioned to you the first step. Okay, okay, so this one you can see this weight. So this one, okay, 1 3. Okay, this one will be declared as the 0.5. Okay, you can see this one and then 2 3 is a 0.4. This one 0.4. Okay, and then this one 1 4 0.9. Okay, and this one 2 4 2 4 1 since 1 1. Okay. And then here will be negative 1.2. This one 1.1. Okay, the bias, okay, it's not bias 1 sorry. Okay, so this bias will be 0.8. This one before is the negative 0.1. Okay, this one bias equals to 0.3 lah. Okay, right? So the learning rate will be 0.1. Okay, first we go for the first iteration. The first 4 iteration, that means the input 1 will be 1, sini will be 1. So the YD, okay, YD is the Y given that I mentioned to you is the 0. Okay, that means we have to find the Y5. Okay, Y5. Okay, to get the Wi-Fi, we have to calculate from this part, okay, from the input. So that I mentioned to you. So maybe I just separate like this. I separate. Okay. Okay. Okay, separate like this. Okay, this one maybe up to you. You want to declare this one? I declare as a S1. Okay, actually it's a 3 lah. Okay, I declare as a S1. Okay, this one 0.5, and this one will be 0.4. Okay, this one will be 1. Okay, this one will be 1. Okay, and then we can get the Y here lah. What is the Y here? Okay, for the second for S. Another one part here, S2 here. S2 is actually is a S4 lah. I declare as the S2 So 0.9 is 1. Okay, so this one 1. Okay, actually we forgot so the bias is a 0.8. Okay, this one bias is a negative 0.1 0.1. Okay, and then we have to calculate the Y. Okay, we declare Y S2, this one Y S1 Okay, so using the formula so first we have to calculate the S1. Okay, similar like simple neural network. First we have to calculate. Okay, I calculate this part so I put here here so S1 S1 B plus summation of Xi Wi. All right, so B is equal to 0.8 plus 0.5 1 plus 0.4 multiplied by 1. So automatically, what is the answer here? You can use your calculator. You can use your calculator. So this is 1.7. All right. So after you get 1.7, we use this formula, Sigmoid function. Y S1 equals to 1 over 1 plus exponent S negative S. S is S1 is the 1.7 1.7. So equals to this one also you can use your calculator. All right, so I just simplified this one, so you can get 0.846. Okay, 846. Okay, for example, this is for example this one. Okay, the next part you have to calculate the for S2. S2 B plus summation of Xi Wi. Okay, X2 is negative 0.1 plus 0.9 plus 1 okay, plus 1 okay, actually it's multiplied by 1 but I simplified this one okay, if confused I put this one plus 1 multiplied by 1. Okay, so the answer will be S2 will be using your calculator 1.8 1.8 okay, 1.8, and then you can use the Sigmoid function to get the Y S2 lah. Okay, Y S2 1 over 1 plus exponent negative 1.8. Okay, equals to this one you can use your calculator also. So 0.858. Okay, this that I mentioned to you. So this output for S1 and Y S2 actually is the input for this one. Okay, that's why next step you have to calculate for Y here. Okay, so first you have to calculate the S. Okay, this one maybe I declare as the S3 lah. This one S5 I declare as S3. So this one this one Y5 lah, I follow Y5. Okay, so we have the bias is 0.3. Okay, so weight here will be negative 1.2, and this one will be 1.1. But the input here will be this one will be 0.846, and this one will be 0.858. This means the output here will be input for this one. The output Y here YS we declare as Y2 S2 or YS4 up to you. This actually is the input for this one for S I declare as S3 lah. Okay, it's the input here. So that's why to calculate the S3 actually is the summation of 0.3 plus 0.846 multiplied by negative 1.2 plus 1.1 multiplied by 0.858. Okay, so you can use your calculator, all right, to get the S3. S3 equals to, when you calculate it, okay, so 0.22229, okay, 229. And then you can use the sigmoid, okay, you can use a sigmoid formula, Y5, okay, here, Y5 here. So actually it's the formula, this one, 1 over plus exponent negative 0.229, okay, equals to, okay, the formula is a 0.557, okay. So this one, the error here, and then we have to calculate the error, okay. After that, after calculate the Wi-Fi here, so we have to calculate the error lah. So maybe I declare the error S3 here, because this one I declare as the S3, S3, this one I declare as the S1, this one I declare as the S2 lah, for simplicity. Alright, similar like middle line. I just use the similar like middle line. Okay, this one I declare as the S3 lah. So error S3 equals to 0. So because this given is 0 minus 0.557. So the error here will be negative 0.557. Okay, this is the error here. The error here. And then after you get the error, okay, so you have to calculate the error gradients. Okay, so the error gradient will be, this is formula for error gradient. Error gradient, okay, maybe I declare as the error gradient S3. So Y S3, okay, 1 minus Y S3, okay, multiplied by S S3 lah. All right, so okay, here Y S3 is okay, Y S3 is 0.557. 1 minus 0.557 multiplied by error is negative 0.557. Okay, so and then the gradient error will be, okay, you can use your calculator, and then negative 0.137. Okay, 137. Okay, gradient error for this one, 0.137. Okay, after that, after you get this gradient error, we have to adapt the weight here. So you can see, so we have to adapt this one. First, we have dimension to you. That's why we call the backpropagation. We have to adapt this one first. Okay, the adapt here. So the weight, okay, this one is the bias, and this we have to adapt this one, weight here, and also the weight here. All right, using the formula. Okay, using the formula. Okay, so I will show the formula. So this one too many. Okay. All right, so this is step lah. You can check on the slide, already give the answer that mentioned to you. So first, okay, this one I declare as the S lah. Okay, this one I declare the S. Okay, so this one is S, and this one is the S. Okay, that's why at the end you can get this one. All right, I skip this one. Okay, this is given. Okay, this formula I mentioned to you is a given, is a 0. Okay, and then this is calculated. Okay, so this is error. All right. Error gradient error gradients. All right, so we have to adapt the weight lah. All right, so using this formula. Okay, so the all will be 1.2 multiplied by plus multiplied by 0.1 multiplied by 0.855 multiplied by negative 0.1375. Okay, so this is this formula lah. Okay, so actually on my slide before this one I declare as the error S3. This one Y S1 lah. Okay, Y S1. Okay, this one based on my slide, I refer this one as the one S1. This one is the I declare as the S3. Okay. And then this is for weight here. You can see this is weight here. Okay. All right, so this one. So first you have to adapt this one, the weight here, and then you have to adapt this one, the weight second, and then you have to adapt this part. Okay, this part. Okay, 0. The bias. Okay, this one the bias lah. All right, so that's why you can see this one. All right, so first you adapt this one, the 0.2. Okay, negative 1.2, and then 1.1, and also the bias is 0.3 lah. Okay, so this is value. There's a value for new weight and new bias lah. Okay. Okay, so this one okay, so this is a new weights and bias. Okay, but this one on the neuron 5, or we declare as the neuron S3. Okay, this one. Okay, this one I declare as the S3 lah, neuron S3. Okay, next you have to adapt the weight and bias at the neuron 3 or declare as the S1. This one S2 lah. Okay, I declare before this S1 and S2. Okay, but before to calculate to adapt the weight and bias, you have to calculate the error gradient lah on the S1 and S2. Okay, so this using this formula. So this one I declare as the S3 is the S1 here. This one I declare as S1. Okay. This one I declare S1. Okay, this one I declare S3. Okay, this one the weight O lah. Weight O lah. Okay, so substitute the formula so you can get this one on this part. Okay, and then for gradient error for S4, this one I declare as a S2. Okay, this one I declare as a S2. This one declare as a S2. This one the same. Okay, this is S3, and this one based on the weight lah. This one the weight on this part So this one the gradient error on this part. You can refer to the figure here. Actually on this part. Okay, on this part Okay, on this part lah to get the gradient error here. So based on this weight Okay, so that's why you can see this one 3.5 and 4.5 lah. Alright. That's why you can get the weight will be weight will be negative 1.2 and 1.1 and then after you get the gradient error for the S1 and S2, you have to adapt the weight and the bias at the you can see this one okay, we have to adapt this one. Okay, after you get the gradient error here, so we have to adapt this part, okay, and this part. Okay, maybe we do separately lah. Okay, first we have to adapt S1 first. Okay, adapt weight and bias lah. Okay, and then after the weight and bias this one for S1, we have to adapt the weight and bias for S2 lah. So that's mean we have here, here, here. Okay. Okay, so that's why you adapt the neuron 3 lah. So this is using the same formula using the same formula, adaptation of the weight. Okay, just substitute the formula lah. Okay, that's why we can get the this is new weight and bias lah for weight at the S1 This we call the neuron S1. Okay, and this one for neuron S4. Okay, all right. Right, so this is formula lah. So that's why you have to remember this formula So the adaptation of the weight is different on this part lah. Okay, this part. Compare then on the output layer The output layer, the adaptation will be multiplied by this one will be multiplied by gradient error. Okay, gradient error at the output lah. Alright, so that is for summary. Before I go for the summary, maybe we can try. Okay, so we just we have another 1 hour. So skip this one. Okay, it's quite okay. So this one how to I end the show because of too many writing here. So I end the show. Okay, so wait. Okay, I will show again. All right. All right. So next, next example. Okay, we try for second iteration. We assume. Okay, this one. Okay, cancel out. Okay, we cancel out. Okay, this one already discussed before this. Now we focus. We assume. We assume this is first iteration. Okay, this one is the first iteration. That means this one will be 1 and this one will be 0. Okay. Right, so let's go. Okay, we have to do one by one. Okay, the first step. Okay, so up to you. So for me, for simplicity, maybe you can we can put as the separate as the S1. Okay, this one 3. This one I change to S1. This one I change to S2. This one I change to S3 lah. Okay, So this is okay. So the the bias will be 0.8. This one 1313 0.5. Okay, this one 0.23 is 0.4. Okay, so this one will be 1, this one will be 0. Okay, so this one y s1 okay, right? So and then for this one I declare as the s2. Okay, so we have the bias before negative 0.1. Okay, so input 1414 0.9, and this one 24 is 1. 24 is 1, and then this is a 1, and this is 0. Okay, you can get the y, you can y as 2. Okay, the first step, let me hint you, I just skip for the formula. So calculate the s. Okay, calculate the s 0.8 plus 1 multiplied by 0.5. Okay, plus this one will be 0 lah, because the input is a 0. Okay, so using your calculator is a 1.4. Okay, 1.4 get to sy2 sy1 1 over 1 plus exponent negative 1.4. Okay, all right, so this one you can use your calculator lah. Try. Okay, try this one follow with me lah. Okay, follow me with me. Okay, try to get the what is the output y s1 lah. Y s1. Okay, so negative 1.4 plus 1. Okay, so the answer will be 0.802 lah. Okay, get this one hopefully you can get this one Okay, so the ys1 is the 0.802. Okay, 0.82, and then for this one s2 equals to this one s1 this one s2. Okay, negative 0.1 plus 0.9 multiplied by 1. Okay, plus 0 lah. Alright, so the formula will be okay, 0.8. Okay, and then using the formula for sigmoid, ys2 equals to 1 over 1 plus exponent of negative 0.8. Okay, so you can try so okay, try with me Okay, I also try using my calculator. Plus 1 divided by, right, so the answer will be 0.669. Okay, 0.69. Okay, that is for s2. Okay, so that means the input for this one okay, for the s3 I will based on this one it's knowing. Okay, so this one b3 is a 0.3, this one 35 is a negative 1.2, and this one 1.1 all right, so to get the s3 here, okay, s3 here, okay, 0.3 plus negative 1.2 multiplied by this one multiplied by 0.802 plus 1.1 multiplied by 0.69. Okay, so you can try. Okay, you can try. Check with my answer lah. Is it my answer is correct or not? So 0.3 plus negative 1.2 0.82 okay, plus 1.1 0 multiplied by 0.196. Okay, so the answer will be 0.1 okay, I just simplify. Okay, so this one actually is 0.0966. Okay, and then I simplify. Okay, to get 0.1 so and then we can get the y s3 equals to 1 over 1 exponent of negative 0.1 Okay, negative 0.1. Okay, negative 0.1. Okay, plus 1 over. All right. So the output here will be 0.525. Okay, 525. Okay, 525. So the error here will be 1. So to get the error, here actually error, you can declare as the error S3. Okay, error S3, that means error D. D is a 1 minus 0.525. Okay, so what is the error here? Okay, so 1 minus 0.525. Okay, so the error will be 0.475. Okay, 475. Right, that is the error. Then we have to calculate the gradients. Okay, the error gradients. The error gradient, that means this is formula for error gradients for S3. Okay, equals to y S3, 1 minus y S3. Okay, multiply by error S3 lah. Alright, so the formula here y S3. Okay, 0.525. 1 minus 0.525 multiplied by 0.475. Okay, to get the gradient, error gradients. Okay, you can follow with me. Okay, calculate. Okay, 1 minus, okay, multiplied by 0.525 multiplied by 0.475. Okay, so the answer for gradient error will be 0.118. So if I'm wrong, please correct me. Correct me. So this one I also manual. So this one, the answer will be for the gradient error gradient will be 0.118. Okay, based on my calculator, 0.118. After get this one gradient error, we have to add the weight here. The weight here, the weight here, and the bias here. So you have to use the formula lah. Okay, I write here. So for weight new, okay, weight new, maybe you can declare this one new. I declare new 3 lah. 3 5 here. So for you understand here, new. Okay, for weight new old, 3 5 old. Okay, plus this formula alpha. Okay, y S1 multiplied by gradients error S3. Alright, so equals to, with all is the 1 point negative, negative 1.2 plus alpha. What is the alpha? 0.1. Okay, multiply by S1, YS1, this one, YS1 0.802. Okay, multiply by gradients. Okay, 0.118. Okay, so try this one. What is the value here? 0.1 multiplied by 0.802 multiplied by 0.118. Okay, so alright, negative 1.2 plus. Alright, so the answer will be negative 1.19. Okay, this is a new weight, new weight for this part. Okay, new weight for this one. The answer will be negative 1.19. Okay, 1.19. And then we have to adapt this one, this weight. Okay, maybe I click here. So weights, we can call as 45 new. Okay, weight 45 old. Okay, but they will be same. Will be same lah. Formula alpha. This one will be YS2. Because this one refer to this one. Not YS1. This one YS2. Because this one is the refer to YS2. Okay, this one. This one will be refer YS2 lah, not refer to YS1. But the error gradient will be same lah. The error is S3 lah. Okay, and then the whole weight will be 1.1. 1 plus, okay, 0.1. Okay, the S2 0.96 multiplied by same lah, 0.118. Okay, so that is the new weight for 45 here. 45 here. Right, so 0.1 multiplied by 0.96 multiplied by 0.118, okay, plus 1.1. Alright, so the answer will be 1.11, okay, 1.11 lah. Okay, so the new weight here will be 1.1, okay, 1.1 1.11. Alright, and then you have to adapt this part, okay, we have to adapt this part lah, okay, the bias here. So the bias formula, okay, bias, maybe you can declare as follow this one as B4 lah, as B5 so B all, alright, so this is new, okay, B all, okay, B all is 0.3, okay, multiplied by alpha 0.1 and multiplied by gradients, okay, gradient error is 0.118, okay, so 0.1 multiplied by 0.118, okay, plus 0.3, okay, right, so that is a new bias, okay, that is a 0.312, okay, 312 lah, right, so that is the new bias here, the new bias here, okay. Alright, after you get this one, okay, we can already get the adapt the weight and bias here. So we have to get the gradient error here. Okay, gradient error here, gradient error. So maybe I declare the gradient error S1. This one gradient error for S2. Okay, so the formula for gradient error I put here lah. Put here. Okay, so this gradient S1. Alright, so y S1, okay, 1 minus y S1 multiplied by, okay, gradients error, okay, this is the gradients error for S3 multiplied by weight all, okay, weight 3/5 all, weight 3/5 all, okay, so YS1, this one 0.802, okay, 1 minus 0.802 multiplied by gradient error, okay, 0.118 multiplied by, okay, negative 1.2. Okay, this is the gradient error for this one, okay. So next I find the gradient error for S2, okay, using the same formula. Which one? Okay, so this one, this part. Okay, the gradient error for S2 equals to YS2 1 minus YS2, okay, multiplied by gradient error. Okay, this one gradient error for S3 multiplied by weight all for 45, weight all for 5 all, this one for all. Okay, for 5 here. Right, so this one for YS2 is a 0.69. Okay, 1 minus 0.69 multiplied by gradient 0.118 multiplied by 1.1. Okay, 1.1. Okay, and then you can get this gradient error for S3. Okay, sorry, S2 here. Okay, S2 and S1. Okay, so you can use your calculator lah to get this one. You can try. What is the gradient error? Okay, for S here, for S1 here. Because this gradient error you can use to adapt the weight here. So the weight here, and also the bias. And also for gradient error S2, you have to use for adapt the bias here. Okay, the weight bias here, the weight here, and also the weight here. Right? Okay, so this one maybe you can try, maybe after this you can try lah. You can try how to get. Okay, I just stop here, to stop on the to get this one lah. Okay, you can try. Okay, so I will try to get the S1. Okay, gradient error gradient for S1. So 1 minus 0.802. Okay, multiplied by 0.802 multiplied by 0.118 multiplied by negative Negative 1.2, 1.2. All right, so the answer will be negative. Okay, so the gradient error for this one, okay, S1 will be okay, negative 0.022. Okay, 22 this one the gradient error for gradient S1 here, the answer will be negative 0.022. Okay, so for this one, okay, try this one for gradient error gradient for the S2 S2, 1 minus 0.69, okay, multiplied by 0.69, multiplied by 0.118, okay, multiplied by 1.1. All right, so this one, the answer will be 0.028. Okay, this is gradient error for S2. All right, after you get this one, so this one you can use for edit this weight and bias. Okay, and then for this one to edit this bias and weight. Okay, I will just try for example to edit the YS3 lah. Sorry, YS3, W13 W13 So W13 which part? Okay, all right, so W13 new. Okay, W13 all, 13 all. Okay, plus. Alright, so this one alpha xi is a x1. Okay, is a x1 here, and then will be multiplied by gradient s1. Alright, s1. So the 13 all is the 0.5. Okay, this one 0.5. Plus alpha is a 0.1. Input, okay, S1 will be here, will be 1. And then multiplied by gradient, gradient S1 is a negative 0.022. Okay. So what's the weight for new 13 new. So okay, 0.1 multiplied by 1 multiplied by negative 0.022, right? And then 0.5. Okay, so the answer will be, okay, the new weight will be here, will be 0.498. Okay, 0.498. Okay, there is new weight here, 13. And then for for W23, okay, W23 here, for W23, okay, W23 new, okay, W23 all, 23 all, okay, plus, put here, alpha, x2, x2, okay, because this one will be on the x2, this one x2 multiplied by gradients, s1, okay, s1, okay, so the weight 2 will be, this one will be 0.4, I put here, okay, 0.4 plus, okay, 0.1, okay, multiplied by x2 is a 0. Okay, x2 is 0 and okay, 0 automatically. So this one, all the value will be negative 0.022. So this one will be 0. So this one will be maintained. So the new weight for this one will be same with the old. So this one will be 0.4. Okay, the new weight. And then next you have to go for this part. Go for adapt this weights. Wait for 114 and 24 and also the B4. Okay, but you have to use this one, gradient error for S2. Okay, alright, class. So next, maybe you can try. Okay, maybe you can try this iteration. Next iteration, this one, Alright, next iteration you can. Okay, so this one we already discussed. This one we can cancel out. Okay, next exercise. You can try this one. Okay, you can try assume this one will be 0. Okay, this one will be 0 and this one will be 1. But the initial value follow this one. Initial value will be follow same. We follow this one. Okay, no need to change to the new iteration. Actually, for example, okay, for the first iteration, we have to adapt this one and this part. And then after the second iteration, we have to follow the initial. Okay, this one, this weight actually. But for this one, I just to share to you how to adapt the weight, the weight and bias. Okay, that's why maybe for this one only one iteration. Okay, we just consider one iteration lah. All right. Next, your part you have to do. Okay, so we cancel out this one. Okay, first next week you can try lah. You can try. This is a first iteration. 011 is the first iteration. All right. Second part you have to try this one. 000 as the iteration number 1 lah. Okay. That means we assume only one iteration lah. So you can see if you have 4 iteration, I think too many pages you have to solve. Okay, so this one you can see lot of mathematical equation that involve only one iteration. Only one iteration. So if we have 2 iteration, I think too long. Okay, too long calculation lah. Okay, after that, so this one, for example, if we have 2 iteration, only 2 iteration, but I think it's very long lah. Okay, for your case, so assume next, okay, assume, okay, this is, you can try by yourself. Okay, try this one. This is as the first iteration. Then after you solve this one, okay, next try for this as the first iteration. Okay. All right, so that's all for the backpropagation algorithm. You can see so how the weight and the bias adapt from the output. Okay, from the output to the input. That's why we call the backpropagation. That means we will be adapt the weight and bias from the output to the inputs. Okay, that's why we can go for the next is the summary. Right, so we have discussed about the multilayer neural network, which is basically feed forwards. Okay, they mentioned to you. Feed actually is the multilayer neural network. Actually, is a feed forward neural model consists of hidden neurons. Okay, we have discussed about the logistic attention function. All right, so we use the sigmoid. Okay, sigmoid function. You have to know lah. Okay, so this is a formula for sigmoid lah. 1 over 1 plus exponent of x. Okay, this is a formula for sigmoid function. So on the simple network, we use the threshold. Okay, threshold also one of the activation function. Okay, these functions are used to in the hidden layer and the output neuron of the backpropagation algorithms. Okay, and then the backpropagation algorithm has been extensively derived. Okay, and then it has been shown how the backpropagation can be used to solve the simple XO problem. Okay, so this one actually is the actually this is XO problem lah. Okay, you can see this one. Some example lah. Okay, this one is actually the XO problem, right? Okay, so your part, okay, this one is quite long, but it's very simple mathematical, but it's quite long. But don't worry, that mentioned to you. So all the formula will be given. The formula will be given, but you have to know lah. For example, the formula will be given like this. Okay, similar like this. Okay, the formula will be given like this. Okay, will be given like this. But you have to know what this mean. Okay, what this mean. The gradient error, error gradient for what? Okay, that's why for example, for my to simplify, that's why I declare as okay, for example, I declare this one as the S1. Okay, I declare this one. For example, you can get this equation, this example. Maybe you can change based on your understanding. Up to you. For example, I change this one for S1, similar like middle line. Similar like middle line. This one I declare as the S1. This one I declare the S2, and this one I declare the S3 lah. Okay, for my simplicity lah. Right, and then the first step will be same all the technique on the neural network lah. You have to calculate the S, the net input lah. Okay, some of the book they refer the net input as the X. Okay, for example, this slide, this slide they refer the net input as the X. Okay, but for previous slide we refer net input as the S. Okay, up to you. You want to follow or you want to change. For example, for me, I just follow for net input as the S lah. That's why I declare this one as the S1. This one I declare as the S2, and this one I declare as the S3. Right. So first step, you have to calculate the net input for S1. All right, after you calculate the S1, and then you can get the output lah. Okay, the output using the sigmoid, okay, using this one, using the sigmoid formula. This is formula, right? So to get this output lah. Okay, so this output actually is the input for this, for the S3, the input for this one this neuron, Okay, and then similar like for S2, for S2 here. So you have to calculate the net inputs, okay, using the formula equals to B plus summation of SIWI, right? So calculate this one, you can get this one, right? And then the YS2 equals to 0.96. So this one, the output here will be input, okay, input for this one, for this S3. So next, you have to calculate the net inputs, okay? Calculate the net input for S3. Okay, after you calculate the net input, you can get the Y. Okay, Y, you can declare as Y3 or Y5, okay, up to you. As long as you understand, it's okay lah. For example, maybe I declare this one as the S3 lah, SYS3. Okay, so I calculate this one, okay, to get YS3, which one, the YS3, okay. YS3, which one, the YS3, okay. Okay, I get YS3, and then I can calculate the error, okay, the error S3 I declare as the error display. So this one actually is a given here. Okay, YD. This one maybe we declare as the YD desired, okay, Y desired, and then minus YS3. Okay, this one YS3. All right, that's why we can get the error here. Okay, the error here. So of error here, so the error here will be, for example, this one 0.475. Okay, and then after you get the error, you have to find the gradients. Okay, this gradient error using this formula. Okay, that's why I declare this one YS3. So similar this one, YS3. So S3, this is standard formula lah. Okay, for this slide, they refer to this one, refer to Y5. Okay, they refer to Y5. Okay, this refer to, because this is neuron Y5. So for my simplicity, I refer this one as the YS3. Okay, YS3. And then this is formula lah. Okay, formula. And then you can get the gradients. Okay, after you get the gradients error for this part, you have to adapt this one. You have to adapt the weight, okay, on the neuron S3 lah. So this one, adapt this one, and for the bias. Okay, after you get this one already, the weight and bias already adapt. So we proceed for calculate the gradient error for S1, and then also gradient error for S2. After you get the gradient error for S1 and S2, you have to adapt for the neuron and bias for every neuron. For example, for S1, you have to adapt B3 here, WY13 and W23. Okay, using this that our error gradient S1, and then also similar like S2. After you get the error gradient for S2, you have to calculate the weight and bias. Okay, bias for B4, new bias for weight 14, and new weight for 24. Right, so that's all for only one. Okay, this one only one iteration. I mentioned to you is only one iteration. Right, so only this part. Okay, so next you have to try lah. Okay, so this one I'll leave it to you. So you have to try. Okay, you have to try. Okay, for the next, maybe you can try at home after this. Okay, so assume this is a first iteration, 0, 1, 1. Okay, assume this is a first iteration. After you finish, until you get the new iteration of the weight 1, 2, 1, 3, 2, 3, B3, and so on. Then next you can try for next 4 iteration, but assume this one as the first iteration. Okay, right. Assume as the first iteration lah. Okay, so this one I leave it to you, so you can try at home. If you have any problem, you can ask me. Right. So, but it is a straightforward lah. It's a straightforward. All the formula will be given. Okay. Right. So you can try. So actually, the step, the real step actually, after you adapt this one, okay, the first iteration, and then you have to go for the next iteration. For the next iteration, all the weight and bias actually will be adapt, follow the new weight and bias lah follow the first iteration. Okay, and then this one also you have to follow the same step, and then adapt the weight and bias. Okay, and then go for the next iteration. After next iteration, also you have to refer to this for previous new weight and bias, similar like this one lah. Okay, but for this one, only for simplicity, just consider for this one already discussed. Okay, iteration 1 and 2 already discussed on the class. So this one you can try. Okay, that I mentioned to you. So assume this one is the first iteration, 0, 1, 1. Okay, the output YD is the 1. It's the first iteration. After you finish, try this one next. For this one, assume as the first iteration, 0, 0, 0. Then calculate the bias and the weights. Okay, all the bias and all the weight lah. So that means we have the 1, 2, 3. We have 9. Okay, we have 9 parameter we have to measure lah. Okay, that means we have the B5, W, V3, W. But to get this, we have to start from input. Okay, to get the S1, S2, and then to get the S3, and then after you get the S3, you can get the error. After you get the error, you can get the error gradient and so on. So that's the step lah for the backpropagation. Alright, so any questions so far? Boleh?
No, Doctor. Everything is clear.
Okay, so next you can try. Next you can try after this. You can try for the third iteration. Okay, in this one, third iteration and fourth iteration is the first iteration. You can try so to how to understand this flow of backpropagation algorithm. Right, so I will stop here. Okay, this is the last topic for our subject. Is for our syllabus. Okay, will be covered for this one, backpropagation algorithm. Right, so for the midterm, it's not, this one not cover lah for the midterm. Okay, for the midterm,